Please, are you talking? I can't hear you.
We are going to continue from where we ended at our last meeting. So we are starting with the power set. The power set. Now, if you are talking about the power set, it's just simply that it's a set of all the possible subsets we can form from a given set. So, assuming if you are having a set A with its elements, then we are not going to form the subset that we can form from all the elements that we have been given for set A. And we put all these possible subsets in a given or in a subset or in the set bracket. And that one is called a power set A. So if I have set A, then the power set is being denoted by P of A. That means we have power set of A. And this power set of A is equal to X is said that X is the subset or equal set of A. So to me, we are forming all the possible subsets that we can get from A, and we put them in the set to get a power set of A. As we are moving on, if you have a question, you can ask, or if you have anything to say. Okay. So power set of A is just simply that you just find all the possible subsets, put them in the set bracket. Get your power set. Now, if you are talking about possible subsets, we can also say that every set, as we are using set A, then set A is set is subset to itself. So every set is subset of itself. So therefore, we are talking about power set, then you have to include that set. That's it. Then also the null set or the empty set is also subset of every set. So it means for every power set, we have two constant members. That one, you know them already. One is the empty set. You have to include it in the power set. Then the other one is the set itself. Now, how can one know that, or the number of subsets that you can form from a given set? Now, the number of subsets we can form is given by 2 power n. 2 power n. Where n is the number of elements or the number of members of that given set. That one now will guide you to know the number of subsets that you want to form so that you put them in a set bracket to get your power set. So example, if you're having A is equal to the set of A, B, then we can check on for the number of subsets we can form, which is equal to 2 power n. So our n now, since we're having two members here, A and B, then our n is 2. So we get 2 power 2. Therefore, we have 4. It means we can form 4 possible subsets from A, B. And these 4 possible subsets that we can form from the set A, we know that the null set is 1. Null set is 1. So that's what you see the null set here. Then the set itself is also included. That's what you see the set A, B also here. Then we form the rest from the set A. So you can get A, the set of A, which will also be subset of AB. Then the set of B. And these two will be just included to make it 4. So we have power set of A, we could call the set of NAR set, the set of A, the set of B, and the set of AB. Therefore, I think it's okay. Okay. Let's see example 1. Given A equals the set of, for all x belongs to the set of odd prime numbers, and x is less than, for all x belongs to the set of odd prime numbers, and x is less than 9. As I explained it for you at our last meeting, now for all x, what is x? X is just odd prime numbers. So you can see that for all odd prime numbers, we want the prime numbers which are less than what? 9. For all odd prime numbers, then the prime of all prime numbers which are less than 9 is the set of A. So the largest set here is the set of the all odd prime numbers becomes the largest set. So you can just find the possible odd prime numbers that you can get. Then among them, then we select those which are less than 9. Is it okay? So if you look at the prime numbers, we have what? The odd prime numbers, we have 3, we have 5, we have 7, we have 11, we have 13, 17, 19, and so on and so forth. Because it become what? The infinite set. We can't just name all of them. But from among the few that we have just listed, now we are not going to select those which are less than 9. And therefore, they will be 3, 5, and 7. 3, 5, and 6. So our set of A now is the set of 3, 5, and 7. Please, are you following? Gentlemen, are you following?
Yes, sir. We are following, sir.
Okay.
Yes, sir, we are following.
So now we have the set of A. And by counting them, how many are there now? You have 3 members of the set of A. Therefore, our n is 3. So if I want to know the number of subsets that can form from the A, then it's 2 power n, where n now is 3. So we can 2 power 3, which is 8. So we might get 8 subsets to form our power set. But don't forget, we know the 2 of them. What are they? What are automatic members?
The null set and
The null set,
original set, that is the 3,
and the
5,
set
and
is
7.
good. So we know the null set here. We have the what? The set is then we form the rest. So you can start with the individual members. So we have the set of 3, the set of 5, the set of 7. Then we pair the 2 of them. So we have the set of 3, 5, the set of 3, 7, and the set of 5, 7. Then the set is to make it 8. Now a caution here. If you are the set of, if you are pairing 3 and 5, don't come back and also pair 5 and 3. Because we are talking about the members, not their positions or their arrangements. So 3 and 5 is the same as 5 and 3 because they are the same members. Is it okay?
Yes, sir.
Good. So that's why we got the set of 3, 5, then 3, 7, then 5, 7. So therefore, the power set of A now is the set of all these, which contains 8 subsets. Example 2. Now find P of B, the power set of B, given that B is the set of for all Y, there exists X. Y is equal to the set of factors of 12, and X is even. For all Y, there exists X. Y is equal to the set of factors of 12, and X is even. So you can simply say that for all factors of 12, there exists at least an even number. That X. For all factors of, you know why is the factors of 12? So for all factors of 12, there is at least an even number. So that even number or number that we want to form the set of B. So therefore, when you go to the factors of 3, we are having what? How many factors? What are they? What are the factors of 12? What are factors of 12?
1.
Yes,
Hello, sir.
yes.
So we have 1, 2, 3, 4, 6, and 12.
1,
2,
2,
3,
3,
4,
4,
6, and 12.
6, and 12. So this is Y. But there exists X. X is even. So we go through all these factors of 12. Pick the even ones among them. That one will be our set of B. Is it okay?
Yes, sir.
Good. So let's pick the even members out of that factor of 12. So we have 2 here. We have 4. We have 6. We have 12. Therefore, our set of B now becomes 2, 4, 6, 12. Now, having gotten your members of set of B, now you cannot go ahead to form the power set. So here we have NB4. Therefore, the number of subsets we are going to get now will be 2 power 4. And that 2 power 4 will be 16. So you have to get 16 subsets. So first we start from the null set. Then we take the set of individual members. So set of 2, 4, 6, 12. Now we pair them. 2, 4, 2, 6, 2, 12, 4, 6, 4, 12, 6, 12. That is pairing. Then we go to the next one. That will be the set of 2, 4, 6, 2, 4, 12, 2, 6, 12, then 4, 6, 12, and the set is there. So we count together 16 subsets. I will put all of them in the set bracket to make it power set. I hope it's okay here.
Yes, sir.
If you have a question as we move along, you can ask, please. Any questions so far? The power set. Any question?
Okay, sir.
Okay. Then, if no question, let's try these examples. Find the power set of A, given that A is equal to the set of X, is said that 2 is less than x and less than 12. So 2 is less than x and x is less than 12. X is multiples of 4. So how can we get the members of A? How can we get the members of A? Yes,
So we will list from 3 to 11. Then
Good.
from 3
So we
to
get it from 3 to what? 11. And then
11
we get the A as what?
are the multiples of 4. That is 4 and 8.
So among them, then you select the multiples of 4. Good. Which is what? 4 and 8. So to me, we have A is having 2 members. Therefore, we are now going to get 4 possible subsets to form the power set. Is it okay? Please, are you okay?
Yes, sir.
Good.
Yes, sir.
Now I'm leaving the power set for you to continue. So let's get the members and then at your own time you just find the power set. I A is equal to the set of for all x is factors of 8. So what is A? What is A here? Yes, what is A?
Hello, sir.
Factors of
Yes,
A is 1, 2, 4,
One,
and 8 is
factors of 8. What are they?
Sir.
1,
Yes.
2, 4, and
1,
8.
2,
1. Yes,
2,
2,
2,
4, and 8.
4,
4 and 8.
8 is
For all x is factors of 8. So it means we need all the factors of 8. And they are 1, 2, 4, and 8. That's our set of 8. Then you cannot get our power set of 8. I. A equal to the set of x is said that for all y, there exists x. Y is positive odd integers less than 15. X is factors of 9. So what the clue here? How can I get the members of A? How can we get the members of A here?
We list all positive odd integers less than 15. Then
Okay,
we
so you
the
find the
factors of
members of
9
the
in
larger
what
set,
list.
which is Y. So list all the members of the what? Positive odd integers less than 15. Then we do it again.
Then we find the factors of 9 in the numbers that we've
Then we
listed
go
less than
into them,
15.
pick out all the factors of 9. That now will be your set of A. Good, you are doing well. You are doing well. Okay, so what are the positive odd integers less than 15? What are they?
1,
Here we
3,
have
1,
1, 3, 5,
1, 3, 5,
7, 9,
and
11, 13.
11, 9,
13.
11, 13.
13. Good. Then among these, which are the factors of 9?
1, 3, and 9.
1,
1,
3 and 9.
3,
1, 3, and 9. Good. So it means you get our A at the set of 1, 3, and 9. Therefore, we cannot form the subset. You are doing well. Ivan. Ivan, what
Yes,
are the
sir.
members of A here? What are the members of A here?
Sir, please, is it for the third one or for the fourth one?
The fourth one. A equal to the set of X is like that. Del exists Y. Y belongs to the set of 0, 1, 2, 3. And X is equal to Y key. So what should you do here?
I think 64.
So what is A? The set of A.
Sir, please, we have 0,
Yes,
1, 8, and 27.
So we are now going to find the set of X, say, the bigger set. Are you okay?
Yes, sir.
So let's find the set of X first. And we are saying X is equal to Y key. I know the set of Y. So when Y is 0, we have X equal to 0. It's okay?
Yes, sir.
Because 0 keeps the same as 0. Then when Y is equal to 1, we have X is also, so let me go here. So when Y equal to 0 here. Okay. So we have X now will also be X is equal to 0 key, which is equal to 0. I hope you are all following.
Yes, sir.
Yes, sir.
Good. Then when Y is 1, what is X? Now you have X will also be equal to 1 key. And 1 raised to the power 3 is the same as what?
1.
1. So we have X is also equal to 1. When Y is 2,
X will be 8.
X will be 8. Good. If you get what? You have 2 keys. So you have X now will be equal to 2 power 3. And 2 power 3 now will be equal to 8. I hope you can all see, eh?
Yes, sir.
I want to make it clearer for you. Okay? So lastly, when Y is 3, then what are you getting for X?
X will be 27.
X will be 27. So we have Y for Y is equal to 3 here. We have X is equal to 27. Good. How did you get that 27?
3 cube.
So you have X is equal to 3 key. Okay, that's good. Then with this, we can now get the set of X as what? What's the set of X now?
0, 1.
Okay, so we have
8,
X now will be
7.
equal to the set of 0, 1. Yes, 0, 1 what?
7. 0, 1, 8, and 27.
8 and 27, good. So now this has now become the set of X. Then if you go to the set given, it is saying that now it is saying that for, okay, we have X is said that there exists what? Y. Then we have y is the set of 1, 0, 1, what? 0, 1, 2, 3. And we are now getting x at the set of also 0, 1, then what? 8
and 20.
and 27. Good. So you could see that if you go to a set of x, there are some members which also belong to what? Y. And these are the members that we need to form the set of A there. How we are getting my point here?
Yes, sir.
Yeah, so if you see this set of x, we are having 0 and then we are having what? 1. These two here are also found in the set of y. Therefore, for x, there exists y. Y belongs to the set of 0, 1, 2, 3, and x is equal to y key. Therefore, that set we are talking about is A now is what? The set of 0 and 1. Agree?
Yes, sir.
So with this, we can now just go ahead to get the power set, because since we have two main elements here, then you can just get the 4 subsets to form the power set. Good. Then the fifth one, you can just do it. For all x, there is y. Now x belongs to the set of prime numbers, and y belongs to even numbers. So what is A now? So the bigger set is x. Okay, so for all prime numbers, there exists some even numbers, or at least an even number. So then what is that set of A? So you can come up with the prime numbers and then check if you can get the even numbers among them. And take all the even numbers among that prime number to get what set of A. Is it okay?
Yes,
so
sir.
what is the set of A?
So please, can you say all even prime numbers?
The question is that for all x and x prime numbers, there exists y, and y belongs to the set of even numbers.
The set of A is 2.
So we can say as we can say that what was the set of even prime numbers. That will give you a set of A. It is the same thing. The even numbers among the prime numbers. Is that okay?
Yes, sir.
Therefore, what is A?
You have 2.
The set of 2. The set of
Yes,
2.
sir.
There's only one member. Now let's form the power set of A for the fifth one. What's the power set? The V. What's the power set for V? That's why we have to do it.
So
What's the
please,
power set?
now set and 2.
So we are P of A now. It was the now set.
Power set.
And 2.
Yes. Now that I what?
And 2.
And the set of 2. And the set of 2. Good. Since we have only one element, that means our n now is 1. Therefore, 2 power 1 is what 2. So therefore, for this one, it gets the null set, and the set is which is 1. The set of 1. That's all. Oh, it's 2, eh? It's 2 rather. Good. But the rest, what to do, find the power set yourself, eh? To get the members, we'll be able to get the members, then you can just find the power set easy. Any question or else we move on to cardinality of a set. The cardinality of a given set. Now, if we are talking about the cardinality of the given set, it's just simply that the number of members that set is having, how many are they? How many members the set having? So just count them and then put it down. So assuming you are having a set A, which is given by the set of A, B, C, D. Then if I want to find the cardinality of set A, then I just count out all the members here. 1, 2, 3, 4. Therefore, we have A has 4 members, hence its cardinality is 4. Is it okay?
So please go over that one again.
Now, I am saying that if you have found the cardinality of a given set, it gets the number of members of that set, or the number of elements of that set. The number, how many are they? So, an example for set A is having the set of A, B, C, D. So when you count that, how many members do we have here?
So 4.
Therefore, the cardinality of A is 4. Because it has 4 members. Is that okay?
Yes, sir.
Yeah, so the cardinality of A now, of a given number, is given by the symbol this. Or at times we can use N, which is N of A. So the number of A. Is okay? So you can either use N or the modular symbol here to determine or the number to denote the number of elements within a given set. Now let's see this example. In the cardinality of the following. A or I. A equal to the set of X is said that A is less than or equal to X. X is less than 20. And X is a member of integer. So before we find the cardinality, you must know the members first. So let's list down the members and then we count them. Is it okay?
Yes, sir.
So what will be the members here? What will be the members here?
4 to 19.
3, eh?
3 to 19, sorry. 3 to
Big word.
19.
19, sir.
3 to where?
19.
3 to 19. 3 to
3 to
19.
19, good.
Yes, sir.
So we are 3 to 19, then we can just go and count it. So there's the set of A. And the cardinality now is what? 17. If you can get 17. Now let's move on to B or II. B is the set of X is said that X is multiples of 5 less than. So in the same manner, you have to list out all the members here. Is it okay? The multiples of 5 which are less than 50. You can get all of them. So that's what gives us 5 up to 45.
Yes, sir.
5, 10, 15. So when you count them, you get 9. Therefore, the cardinality of B is 9. I. D is equal to the set of, for all X. X belongs to the set of integers less than 30. X is even. How do we get our C? For all X. So for all integers less than 30, X is even. To make it simple. For all X and X is integer less than 30, So you can do that for all integers less than 30, x is even. So what would be the set of C?
Start 2, 4, 6, 8, 10, up to 28.
So we want the even integers, okay, even integers, which are less than what, 30. Even integers, which are less than 30. So you start from where? 2, 4, 6, then up to 28. Good. Therefore, you can count them to get the cardinality. So when you count, you get 14. Hence, it's 14. Did I go, Florian?
Yes, sir.
Yes,
Any
sir.
question for me?
No question, sir.
Okay, then let's see how to get the cardinality of a union when you combine two or more sets together. Yeah, how can you find the cardinality of that? Now, if I have the set of A and B given with their numbers, if they are all finite sets, they are finite. We know all their members. The numbers of elements in A, B is denoted by the cardinality of what A, B like this, or N of A, B. So here, it's a matter of just find the number of A, the members of A, add it to the members of B. Okay, so we have N of A plus N of B. Then say some people may, or some elements may belong to both A and B. Then when you count A, they're being counted. Then when you count B too, the same element will be counted. Therefore, some of them will be counted twice because they belong to both A and B. And for that matter, if you want to get the clear number of the entire maybe element, then you must subtract those who have been counted twice from it. So you must just subtract the intersection, those who have belong to both, the number of those that belong to both sets from the A and B. So therefore, you have N of A B now will be equal to the number of A plus the number of B minus the number of A intersection B. That one now will be if you are using this formula. Now, if you have a text with all the members being listed, then you can first just find the union between A and B, and then whatever you get, then you just count the number of elements that you have got. The same thing. Now, similarly, we are having three of them, A, B, C. So you want to find the number of A, B, C. Then the same thing. We find number of A plus number of B plus number of C. Then after that, you pair them, minus number of A into B. Now minus number of A into C, minus B into C. Then after this, then you add the number of those that belong to both, all of them, A, B, C. There are three intersections. Then you add it to it. You get the same thing. Or add with it to the second one if the members are being listed. Or if you can list all the members down, then you can just find the union between the three sets. Then after that, you count the members that you have got. Are you okay?
So please, go over, please.
Let's use the example to just elaborate it. Are you okay?
Okay, sir.
So let's take the example one. Given A equal to the set of 1, 2, 3, 4, 5. B equal to the set of 2, 3, 4, 6. And C equal to the set of 3, 4, 6, 8. Find I. N of A, B. The cardinality of A, B. II. The cardinality of A, B, C. Is that okay? So if we are going by the first approach, now let me find my first, let me just find my A, B. So this is my A, B. We know how to do how to combine the two sets. It's okay? So we have a set of A here is 1, 2, 3, 4, 5. Now the B is 2, 3, 4, 6. So to me, 2, 3, 4, 6 are all here. We only have the six to be added or included. Therefore, A B now becomes the set of 1, 2, 3, 4, 5, 6. Is that okay with that?
Yes, sir.
Are you okay?
Yes, sir.
Good.
Yes, sir.
So now how many are there? Let's count that. The cardinality. So we have N of A, B. So let's count the members. How many are there?
6.
Therefore, the N, B now is what? N of A, B now is 6. So cardinality of A, B is 6. Now, let's also find the union of all the characters ABC. ABC. So we have 1, 2, 3, 4, 5, 6. Now will be for what? A, B. Now let's also join it with the C. C is also having 3, 4, 6, which are already been captured. That will just include the 8. So therefore we have A, B, C now becomes what? 1, 2, 3, 4, 5, 6, 7, 6, 8. Is okay?
Yes, sir.
Then how many are they now? How many? You count them. That's the cardinality. So when you count them, you get. So the number of
There are
A,
7.
B, C now is 7. Any question here before I move on to that other approach? Is there any question here?
Sir, please go over again, sir.
Where? Where should I go over?
Sir, where the II2, the II2.
Can you find the A, B, C?
Yes, sir.
You can find it.
Yes, sir.
We are combining the members of A, B, and C together, but no repetition.
Okay.
That's the union.
Okay.
So if you look at the A is 1, 2, 3, 4, 5. Now B 2, 3, 4, 6. So
6.
all 2, 3, 4 are already here. Are you okay?
Yes, sir.
We have the same to be included here. So we have 1, 2, 3, 4, 5, 6. For A, B. Which is this one. Then we are not going to join this one with the C to get A, B, C. But look at the A, B, we already have 1, 2, 3, 4, 5, 6. And we got the C is also having 3, 4, 6, 8. 3, 4, 6, 8 are already be captured in A, B. Is okay?
Yes, sir.
So what is left is the 8. So bring the 8 inside to make it A, B, C. Form it to get it.
Okay.
And
It's understood.
Then after that, you count them to get the cardinality. You count them.
Yes, sir.
Yes. Now let's do the alternate approach. I've explained to you about this one, the topic. A, B now, N of A, B equal to N of A plus N of B minus N of A inter B. So let's count then the number of A or find the cardinality of A. How many are there? You have 1, 2, 3, 4, 5. So the N of A is 5. Is that okay? What is n of b? Count them. 4. What is n of c? 4. Are you all following?
Yes, sir.
Yes, sir. Yes, sir.
N of 8, 5 here. N of b, 1, 2, 3, 4. Which is 4? N of c, 1, 2, 3, 4. Which is also 4 here. Then we need the number of those that belong to both A and B. So if you look at A here, we have 2 here, we have 2 also here. So we have 2 common to both A and B, 3 common to both A and B, 4 common to both A and B. Therefore, A intersection B now will be the set of 2, 3, 4. Therefore, let's find the n of that, or the candidate of that. That's why it's clear. Please, are you okay with that?
Yes, sir.
Yes, sir.
Good. So now we are not going to do the above formula to get find that n of A, B. So we have all this. Therefore, I. The n of A, B now become n of the n of A plus n of B minus n of A into B, or the cardinality of A plus that of B minus that of A into B. We know the cardinality of A is 5, that of B is 4. Are you okay? Minus for both A and B is 3. Therefore, we get 9 minus 3, which is 6. I want to put all of them together and then we count and we also got 6. No, no, true. Let's go back and see. See what we got here. So we're having the same thing. Good. Now let's do the same thing for II. Now II too, we just find the cardinality of A, B, C. Then we find that of A into B, A into C, and B into C. So if you look at that of A into B, now already we use this one here. So A into B now is 3. Now let's see A into C. A intersection C. We have 3 here and 4. Okay, so we have here 2 here. 3, 4. Put it also 3, 4 here. So therefore, the set of A into C is 3 and 4. The set of 3 and 4. Hence, the cardinality now is what 2. What about B into C? This and that. So B into C, we have 3 here, we have 4 here, we have 6. So B into C now becomes the set of 3, 4, 6. Hence, the cardinality of B into C is also 3. That's what we have here. This. Then we find the intersection of all the traces. Let's go there and see. So I want to get the element or member that belongs to all the traces. Are you okay? So I think we have 3 here. We have 3 also here. We have 3 also here. So 3 is part of them. We have 4 here, 4 here, 4 here. So 4 is also part. Now 6 is not here, but 6 is also find both B and C. So therefore 6 is not part. Therefore, we have only 2 members or numbers that belong to both all the traces A, B, and C. Hence, the number of A into B into C is also 2. Therefore, the cardinality of A, B, C now becomes is equal to that of A plus B plus C. Then minus that of A into B, which is 3 here, minus A into C, which is 2, minus B into C, which is 3 here. then plus the intersection of all the three things, which is 3. So if you simplify all this, you also get the same, which is the same as what you got when you put them together and they counted the number of elements within. It's okay now. Are you following, please?
Yes, sir.
Good. So it is not any big deal here. Eh? Okay, let's see. At time 2, we may not be able to use the first approach, whereby you find the union and then you count them. At time, they will give you the cardinality or the individual thing. So to me, by all means, either you use the Venn diagram or you go by the the formula. So don't say that the first one is very simple. Why not find the union and then count them? Not all the time you can apply this approach. So let's do this example. Now you have at the end of GTT course registration, it revealed that 50 students of BIT level 100 students at whole campus were able to register. Out of 50, 30 registered for communication skills, that is C. 25 registered for French, F, and 15 registered for digital structure, D. If 8 registered for both communication skills and French, 10 registered for com skills and digital structure, and 5 registered for French and digital structure. If all the students registered at least one of the courses, find the number of students who registered for all the 3 courses. So here we are talking about the cardinality. We will be given almost all the cardinality apart from the intersection of all the 3 courses. So here you can't just go and then list down the members. No, you must go by the formula or can draw the Venn diagram. Good. Now you have been denoted the giving represent the various courses by their initiatives or their initials. So we have the F is for French, the com is for C, and this structure is for D. So we can get N of C, which is 25, N of F, which is N of C is 30, N of F is 25, and N of D is 15. Then we have the intersection of the 2 of them. So we have N of C inter D. Excuse me, I'm coming. Now, when you come back here, we have all the various cardinalities. Now, in all, 50 students registered for all the 3 courses. No, for the 3 courses in all. Therefore, we can say that you have C, D, F. So the number of those that register for com skills or digital structures or French is equal to 50. So that's why the union. So we can get the cardinality of that, or N of C, D, F is equal to 50. So you know that one. Then you have N of C, that the constant alone is 30. N of F is 25, and that of D is 15. We have N of C inter F, which is 8. Then we have N of C inter D, which is 10. n of f into d, which is 5. But we are asked to find those who register for all the 3 courses. We don't know, so we can represent that one by x. But since we know the cardinality of the union of a 3 set, then you can just go and then substitute them into that formula. So the number of n, the number of c, d, f now will be equal to the number of c plus the number of d plus the number of f minus the number of c into d minus c into f minus d into f. Then plus those for all the 3 courses, c into d into f. So we just do our substitution. So we have 15 here equal to 30 plus 15 plus 25 minus 10 minus 8 minus 5 now plus x. So when you simplify all this, you are going to get x is equal to 50 minus what? 47. Because simplify all, you get 47. Therefore, the answer now becomes 3. So it means only 3 people register for all the 3 courses. That's the cardinality. Is that point okay? Is that okay?
Yes, sir.
Good.
It's okay. It's okay.
So this
Yes,
one,
sir.
if you draw a Venn diagram, you come back to this formula. When you draw a Venn diagram, you come back to this formula. Is that okay?
Yes, sir.
But I'll just advise you to also just draw a Venn diagram at your own time and see what you're going to get. You get the same formula. Okay, let's move on to the relationship between sets. How sets relate or related or are related. So we're having success as 1. Now you already know, or as we saw it at our last meeting, if A is subset of B, then it means all the members of A are found in that of B. And it's also possible that all the members in B are also found in what? A. And when it happens that way, we have subset or equal set. It's okay. So we are given 2 finite sets, x and y. If every element of x is an element of y, then set x is a subset of y. And it's being written as x is subset of y, or x is subset or equal set to y. Now, example, given x equal to the set of A, B, and C, y, P, Q, R, A, B, W, C, and Z, we have P, Q, R, A, S. Now, if you compare x and then y, you can see that all the elements of x, you have A here, you have A here, you have B, you also have B here, then we have C in both sets. Now, all the members of X are found inside that of Y, but not every member of Y is found in X. So we can say that X is subset of Y. I will carry the symbol like this. Now, when we just do the same thing to X and Z, we can see that even though some of the elements of X are found in Z or Z. Now we have A is there, and we have C also there, but B is not there. And we have P also in Z, P is also not in X. Therefore, we say that X is not subset of Z, and Z is also not that of X. Is that point okay? Is that one okay?
No, sir.
Is
Please
okay?
go well for me. Please, it's not okay.
Now, if you look at the members of, if you check the members of X, all of them are found in Y. But not every member of Y are found in X. So I think we can find X inside the Y. Okay, now X inside the Y means when you go to Y, we have A, B, C, which is the same as X. So you say that Y contains X, which is the same as Y, X is subset of Y. And here Y becomes the superset of X. Is that okay?
Yes, sir.
Yes, sir.
Good. Now, if you compare X and Z2, not every member in X is also found in Z. And not every member in Z is also found in X. So therefore, we can't say that X is subset of Z. Or Z is also subset of X. No. Okay. Now, since X is subset of Y and Y is not subset of X, now we call this kind of subset proper subset. You call it proper subset. So that we don't put any bar under here. That we don't want to include the bring the what equality here. So we have X is just subset of Y. No equality sign. I call the proper subset. Now, example. Let X be equal, let A be equal to the set of X is said that 3 is less than X and X is less than or equal to 12. The set of B is equal to the set of X is said that X is positive integers less than 15. So here, if you want to check if one is subset of other, you can just list down the members by using the router out method. So you know that if X is greater than 12, then you just list the members down here. We have 4, 5, 6, 7, and so on and so forth. Then we have X is B is also positive integers less than 15. So the positive integer less than 15 now will also become 1 up to 14. So here you could see that all the members of A are inside that of B. Therefore, we say that A is proper subset of B. Why proper? Because not every member of B is also found in A. Example is 1, 2. 1 and 2 are for B, but they are not inside A. But all these members of A are found inside B. Therefore, we have the proper subset. Now, if you look at the next point, we are saying that every set is subset to A set. Now, you mentioned this one when we were doing the power set. Power set. We said the null set and then the set A set are part of the power set. So we are saying that every set is subset to A set, which is true. Then, assuming we are having the set X, then this set X is subset or equal to what? X. Because every set is subset to A set. And if X is subset to X, now don't forget X is also the same as X. Therefore, this Y is not a proper subset. So we put the equal sign here. Or we put a bar under the sign to make it subset or equal. I hope you are getting my point here.
Yes, sir.
Now,
Yes, sir.
example is X is the set of A, B, C. Now you are saying that this X is subset to A6. So it means here is A, B, C. Here is also A, B, C. Now you can see that X here is subset because all the members of X here are found the members of X here because they're the same set. Then X is also equal to what? X. Hence, we have X is subset or equal to X. Now, if a set is subset or equal, then that property of set is called we call the reflexive property. We call the reflexive property. That when a set is subset to a set, that property is called the reflexive. It's okay? The reflexive. Good. So every set is subject to itself is called the reflexive property of a set. Now, if you want to prove it, if X is a member of A, then X is a member of A. Because we are saying that every set is subject to A set. So A is equal to A. So if you take any element of A, for the first one, A, any element of X that belongs to the first A, then the same element of X is also belongs to the second A because A is equal to A. So by the repetition of the statement, it means that X is subset or equal set of X. Now, if X is subset or equal to X, equal to Y, then it doesn't necessarily mean that Y is also subset or equal to what? X. Take note of that. So far, we are now got to know the reflexive property of a given set. That is, a set is subset or equal to a set. Now, another point is saying that if you are having the three sets A, B, C, and we have A is subset or equal set to B, we also have the B is also subset or equal to C, then we can say that A is also subset or equal to C. Two of us.
True, sir.
Is it true of us?
It's true, sir.
True. Why true? Why true?
Since A is a subset of B
Yeah.
and B is also a subset of C,
Yeah.
then it literally implies that A is already inside C.
Now, if you could remember when we were doing the logic, we made mention similar thing here. There. Are you okay? And we call the law of syllogism. If A implies B and B implies C, then A implies C. Is that okay? Now, A is
Yes, sir.
inside the circle of B. A is out of B means we have A inside B. So here become B. And here become A. Is that okay? And the B is subset of C also means B is also inside what? The C. And this is our B. And this B must be inside the C. So this is our C. So now what is A?
A is inside B.
A is inside B and A is inside what again?
A is equally inside C, sir.
Now you A is inside the B and B is also inside C. So you can say that A is inside C. Can you say that? Open your eyes, please.
Yes, sir, we can say that, sir.
A itself is inside B. And the whole B, if you have A inside H, it's also inside C. Are you okay? Then what can you say? We can also say that now A is also inside C. So could that the second C now is here from all these fields are the second C. Oh. And then we can find A there. So therefore, A is also inside C. So in the logic, we call that property as what? The law of syllogism. So if it were to be a logic, then you can say that now this is a valid argument. Because we are seeing A inside B and A inside C. So it becomes a valid argument. But when we come to the set here, we have a property called the transitive. So what happens that we call the property of transitive. So we have A is subset or equal to B. We can change rule here. So A implies B, B implies C, or implies A implies C. So A is the subset of B, B is also subset of C, implies A is also subset of C. And this is what we call the transitive property of set. Is okay?
Yes, sir.
So first we have seen the reflexive property that a set is subset or equal to a set. That reflexive property. Now you have seen that you haven't said that A is subset of B and B is also subset of another set. C, then we can conclude that A is also subset of the last set, C. And that property is called the transitive property. Transitive. We are now having two properties here for sets. One, reflexivity, and two, transitivity. Okay, let's see how we can just prove this one. Now for A is subset of B, and then B is also subset or equal to C. We can let X be a member of A. So if X is a member of A, it means and A is also inside B. So what can you do? You can also say that X is also a member of B. Two of us.
True, sir.
Good. Let me go over that one again. Maybe some of it is not getting it right. Now we say A is subset or equal to B. Now we have just selected one member of A. So we have let maybe X be a member of A. So if X is a member of A, we can also say that then that X is also a member of B. Because X, A itself is inside B, and whatever belongs to A belongs to B. Is okay?
Yes, sir.
Good. So now let's go for B also is subset or equal to C. Now we have X is inside A, implies X is inside B. Now this B is also now found itself inside the C. So therefore you can also say that X is also inside it. Therefore, A is subset of B and B is also subset of C. It also implies A is subset of C. And as I have just mentioned it, we can prove it using Venn diagram, as we did to the law of syllogism in the logic. We can also apply the Venn diagram. Now that is how it is. So we have A here. It's subset of B. So A found itself inside B. And B itself also found inside C. So therefore we have A is also inside C. And this is the law of syllogism. So I'll just ask you, maybe urge you to also try this. Now, given A equals the set of X says that X belongs to R, that's a real number. And X squared minus 4X plus 3 is equal to 0. B is also equal to the set of X, the set of what? Positive what? Integers including 0, or set of whole numbers. And 1 is less than or equal to X, X is less than or equal to 4. Prove that A is subset of B. So we are going to try this one. We are going to try this one. Any question? I don't want that to maybe spend much time here. Any question? Or else we can go. Any question? Any question?